What's the DNS_MSTCS zone for the forest root domain used for? Active Directory AD uses DNS as its locator service to support the various types of services that AD offers, such as Global Catalog, GC, Kerberos, and Lightweight Directory Access Protocol, LDAP. Other non-Microsoft services can be advertised in the DNS, including but not restricted to non-Microsoft implementations of LDAP and GC. However, sometimes clients might need to contact the Microsoft-hosted service. For that reason, each domain in DNS has an _MSTCS subdomain that hosts only DNS SRV records that are registered by Microsoft-based services. The NetLogon process dynamically creates these records on each domain controller, DC. The _MSTCS subdomain also includes the Global A Unique Identifier, GUID, for all domains in the forest and a list of GC servers. If you install a new forest on a system that runs Windows Server 2003 and let the GPO wizard configure DNS, GPO will actually create a separate zone called _MSTCS.forest_name on the DNS server. This zone is configured to store its records in a forest-wide application directory partition, forest zones, which is replicated to every DC in the forest that runs the DNS service. This replication makes the zone highly available anywhere in the forest. Support.microsoft.com web link. What are SRV records and why they are important for proper functioning of Active Directory? Windows 200X Active Directory AD uses the service location mechanism that the Internet Engineering Task Force, IETF, Request for Comments, RFC, 2782 specifies. This RFC shows how clients can use DNS SRV records to locate network services on the network. The SRV records of a domain controller in the domain plays an important role in Active Directory. Active Directory cannot work without a DNS server. The DNS server in Active Directory is used to locate domain controllers in the forest or domain with the help of SRV records. Service records or SRV records are registered specifically for domain controllers when you promote a member server to domain controller. The NetLogon service on domain controller is responsible to register SRV records. So now you understand that Windows 200X domains rely heavily on DNS entries. Let us see some of the important SRV records created by NetLogon service for a DC. _LDAP._TCP.its domain name enables a client to locate the W2K domain controller in the domain named by its domain name. A client searching for a domain controller in the domain patri.net would query the DNS server for _LDAP._TCP.patri.net. _LDAP._TCP.sitename._sites.its domain name enables a client to find a W2K domain controller in the domain and site specified, for example, _LDAP._TCP.lab._sites.patri.net for a domain controller in the lab site of patri.net. _LDAP._TCP.pdc._MSTCS.its domain name enables a client to find the PDC Flexible Single Master Object, FSMO, role holder of a mixed-mode domain. Only the PDC of the domain registers this record. _LDAP._TCP.gc._MSTCS.its tree name enables a client to find a Global Catalog, GC, server. Only domain controllers serving as GC servers for the tree will register this name. If a server ceases to be a GC server, the server will deregister the record. _LDAP._TCP sites.gc._MSTCS.its tree name enables a client to find a GC server in the specified site, for example, _LDAP._TCP.lab._sites.gc._MSTCS.patri.net. _LDAP._TCP.domain.git.domains._MSTCS.its tree name enables a client to find a domain controller in a domain based on the domain controller's globally unique ID. A GID is a 128-bit, 8-byte, number that generates automatically for referencing Active Directory objects. DNS domain name enables a client to find a domain controller through a normal host record. After running promo, a text file containing the appropriate DNS resource records for the domain controller is created. The file called netlogon.dns is created in the %systemroot %system32 /config folder and contains all the records needed to register the resource records of the domain controller. Netlogon.dns is used by the Windows 2000 NetLogon service and to support Active Directory for non-Windows 2000 DNS servers. Explain the structure of an SRV record. Defined in RFC 2782. The SRVRR identifies the hosts that will support particular services. The MXRR is a specialized example of service discovery, while the SRVRR is a general-purpose ORR to discover any service. The SRVRR allows control over prioritization of delivery and usage. It is not widely supported except notably by OpenLDAP and increasingly by VoIP systems in conjunction with an AppDRR. Ugly format may not be helping. The theory behind SRV is that given a domain name, for instance, example.com, and a service name, for example, web, HTTP, which runs on a protocol, TCP in the web case, a DNS query may be issued to find the host name that provides such a service for the domain, and which may, or may not, be within the domain. See example 2 below. SRV syntax. Service.prot.name TTL class wait port target. _http._tcp.example.com. In SRV05 www.example.com. Field description. Service defines the symbolic service name, CIONA port numbers, appended with __. Case insensitive. Common values are _HTTP, web service. _FTP, file transfer service. _LDAP, LDAP service. IMAP mail service. _KIXREP, KIX repository, X.509 certificates. Prot defines the protocol name, CIONA service names, appended with __. Case insensitive. Common values are _TCP, TCP protocol. U.D.P, UDP protocol. Notes, use of SRV and KIX, X.509, handing. RFC 4210 defines service names of certificates, CRLS, keys, prevocations all with the protocol of TCP to indicate the use of the CMP protocol over HTTP/HTTPS. Thus a certificate store supporting CMP may be discovered for the domain example.com by a query for _certificates._tcp.example.com. In a slightly bizarre variation, RFC 4386, informational status, also defines the use of the _KIXREP service for discovery of X.509 certificate repositories and other KIX services. The protocol field contains what other users of the SRV define as the service name. Thus for the service name _KIXREP the protocol values would be _LDAP, the certificate repository server uses LDAP. _HTTP, the certificate repository server uses HTTP. _EXP, the server provides an online certificate status protocol service. One assumes that additional values such as _CMP, _SBCP or _CRL, X.509/KIX protocols, could also be used to describe alternative KIX services even though these are not mentioned in RFC 4386. Finally OCSP, RFC 2560, suggests the service can run over many transport protocols such as LDAP, HTTP or SMTP, and thus the SVR definition proposed for KIXREP service would not contain enough information, because it does not differentiate between a number of possible transports, to allow true service discovery. altogether a strange RFC. Name incomprehensible description in RFC 2782. This OR obeys the normal name rules such that leaving the entry blank, without a dot, will substitute the current zone root, or the current $origin, or you can explicitly add it as in the above _http._tcp.example.com. With a dot. TTL optional. Standard TTL parameter. For more information about TTL values. Class optional. Standard class parameter. Normally and for Internet class. For more information. The relative priority of this service, range 0 to 65,535. Lowest is highest priority, usage is the same as in XPref field. Wait used when more than one service has the same priority. A 16-bit unsigned integer in the range 0 to 65,535. The value 0 indicates no weighting should be applied. If the weight is 1 or greater, it is a relative number in which the highest is most frequently delivered, that is, given two SRV records both with priority equals 0, one with weight equals 1 the other weight equals 6. The one with weight 6 will have its OR delivered first 6 times out of 7 by the name server. Port. Normally the port number assigned to the symbolic service, but this is not a requirement. For instance, it is permissible to define _HTTP service with the port number of 8100 rather than the more normal port 80. Target. The name of the host that will provide this service. Does not have to be in the same zone, domain. May be just a host name or a FQDN. Explain the difference between iterative and recursive DNS queries. With a recursive name query, the DNS client requires that the DNS server respond to the client with either the requested resource record or an error message stating that the record or domain name does not exist. The DNS server cannot just refer the DNS client to a different DNS server. Thus, if a DNS server does not have the requested information when it receives a recursive query, it queries other servers until it gets the information, or until the name query fails. Recursive name queries are generally made by a DNS client to a DNS server, or by a DNS server that is configured to pass unresolved name queries to another DNS server, in the case of a DNS server configured to use a forwarder. An iterative name query is one in which a DNS client allows the DNS server to return the best answer it can give based on its cache or zone data. If the queried DNS server does not have an exact match for the queried name, the best possible information it can return is a referral, that is, a pointer to a DNS server authoritative for a lower level of the domain namespace. The DNS client can then query the DNS server for which it obtained a referral. It continues this process until it locates a DNS server that is authoritative for the queried name, or until an error or timeout condition is met. This process is sometimes referred to as walking the tree, and this type of query is typically initiated by a DNS server that attempts to resolve a recursive name query for a DNS client. What is the difference between a secondary zone and a stub zone? A secondary zone is a read-only copy of the primary zone. A stub zone is a read-only copy of the primary zone that contains only the resource records that identify the DNS servers that are authoritative for a DNS domain name. Explain Active Directory integrated zones. DNS servers running on domain controllers can store their zones in Active Directory. In this way, it is not necessary to configure a separate DNS replication topology that uses ordinary DNS zone transfers, because all zone data is replicated automatically by means of Active Directory replication. This simplifies the process of deploying DNS and provides the following advantages. Multiple masters are created for DNS replication. Therefore, any domain controller in the domain running the DNS server service can write updates to the Active Directory integrated zones for the domain name for which they are authoritative. A separate DNS zone transfer topology is not needed. Secure dynamic updates are supported. Secure dynamic updates allow an administrator to control which computers update which names, and prevent unauthorized computers from overriding existing names in DNS. Windows Server 2003 DNS Active Directory stores zone data in application directory partitions. The domain partition was the only Active Directory storage option in Windows 2000 Server, and it is available in Windows Server 2003 DNS for backward compatibility. The following DNS-specific application directory partitions are created during Active Directory installation. A forest-wide application directory partition, called Forest DNS zones. Domain-wide application directory partitions for each domain in the forest, named domain DNS zones. What is a stub zone? A stub zone is a copy of a zone that contains only those resource records necessary to identify the authoritative domain name system, DNS, servers for that zone. A stub zone is used to resolve names between separate DNS namespaces. This type of resolution may be necessary when a corporate merger requires that the DNS servers for two separate DNS namespaces resolve names for clients in both namespaces. A stub zone consists of the start of authority, SOA, resource record, name server, NS, resource records, and the glue A resource records for the delegated zone. The IP address of one or more master servers that can be used to update the stub zone. The master servers for a stub zone are one or more DNS servers authoritative for the child zone, usually the DNS server hosting the primary zone for the delegated domain name. You can use stub zones to keep delegated zone information current. By updating a stub zone for one of its child zones regularly, the domain name system, DNS, server that hosts both the parent zone and the stub zone maintains a current list of authoritative DNS servers for the child zone. Improve name resolution. Stub zones enable a DNS server to perform recursion by using the stub zones list of name servers, without needing to query the intranet or the internal root server for the DNS namespace. Simplify DNS administration. By using stub zones throughout your DNS infrastructure, you can distribute a list of the authoritative DNS servers for zone without using secondary zones. However, stub zones do not serve the same purpose as secondary zones, and they are not a valid alternative to secondary zones with regard to redundancy in load sharing. When a DNS server loads a stub zone, it queries the master servers, which can be in different locations, for the necessary resource records of the authoritative servers for the zone. The list of master servers may contain a single server or multiple servers, and the list can be changed anytime. Explain the ways of partitioning a DNS database. Explain zone delegation. A DNS database can be partitioned into multiple zones. A zone is a portion of the DNS database that contains the resource records with the owner names that belong to the contiguous portion of the DNS namespace. Zone files are maintained on DNS servers. A single DNS server can be configured to host 0, 1 or multiple zones. Each zone is anchored at a specific domain name referred to as the zone's root domain. A zone contains information about all names that end with the zone's root domain name. A DNS server is considered authoritative for a name if it loads the zone containing that name. The first record in any zone file is a start of authority, SOA/RR. The SOA/RR identifies a primary DNS name server for the zone as the best source of information for the data within that zone and as an entity processing the updates for the zone. A name within a zone can also be delegated to a different zone that is hosted on a different DNS server. Delegation is a process of assigning responsibility for a portion of a DNS namespace to a DNS server owned by a separate entity. This separate entity could be another organization, department or workgroup within your company. Such delegation is represented by the NS resource record that specifies the delegated zone and the DNS name of the server authoritative for that zone. Delegating across multiple zones was part of the original design goal of DNS. The primary reasons to delegate a DNS namespace include a need to delegate management of a DNS domain to a number of organizations or departments within an organization. A need to distribute the load of maintaining one large DNS database among multiple DNS servers to improve the name resolution performance as well as create a DNS fault-tolerant environment. A need to allow for a host's organizational affiliation by including them in appropriate domains. The name server, NS, RRs facilitate delegation by identifying DNS servers for each zone, and the NS RRs appear in all zones. Whenever a DNS server needs to cross a delegation in order to resolve a name, it will refer to the NS RRs for DNS servers in the target zone. What is the process of DHCP for getting the IP address to the client? There is a four-way negotiation process: BW client and server. DHCP discover, initiated by client. DHCP offer, initiated by server. DHCP select, initiated by client. DHCP acknowledgement, initiated by server. DHCP negative acknowledgement, initiated by server if any issues after DHCP offer. What is a DHCP lease? DHCP lease is the amount of time that the DHCP server grants to the DHCP client permission to use a particular IP address. A typical server allows its administrator to set the lease time. We've installed a new Windows-based DHCP server, however, the users do not seem to be getting DHCP leases off of it. What could be the reason? The server must be authorized first with the Active Directory. Explain the licenses that can be managed by TS Licensing Server in Windows 2003. To use Terminal Server in your organization, you are required to have a Windows Server 2003 license for every terminal server that you deploy in your organization, as well as Terminal Server Client Access Licenses, CALs, for devices that access the terminal servers. For terminal servers that are running Windows Server 2003, there are two types of terminal server CALs. Per device. Per user. Which CAL you choose depends on how you plan to use terminal server. By default, terminal server is configured in per device mode, but it can be switched to per user mode using the Terminal Services Connection Configuration (TSCC) tool or by using Windows Management Instrumentation (WMI). Per device licensing mode. A per device CAL provides each client computer the right to access a terminal server that is running Windows Server 2003. The per device CAL is stored locally and presented to the terminal server each time the client computer connects to the server. Per device licensing is a good choice for hosting a user's primary desktop for devices the customer owns or controls. Then clients or computers that connect to a terminal server for a large percentage of the working day. Hosting line of business applications that are used for the bulk of your users' work. This type of licensing is a poor choice if you do not control the device accessing the server, for example computers in an internet cafe, or if you have a business partner who connects to your terminal server from outside your network. Per user licensing mode. In per user licensing mode you must have one license for every user. With per user licensing, one user can access a terminal server from an unlimited number of devices and only needs one CAL rather than a CAL for each device. Per user licensing is a good choice in the following situations. Providing access for roaming users. Providing access for users who use more than one computer, for example, a portable and a desktop computer. Providing ease of management for organizations that track access to the network by user, rather than by computer. In general, if your organization has more computers than users, per user licensing might be a cost-effective way to deploy terminal server because you only pay for the user to access terminal server, rather than paying for every device from which the user accesses terminal server. Check the end-user license agreement for the applications that you plan to host to determine if they support per-user licensing. How can you override the license server discovery process and set your preferred license servers? When terminal services is started, the server attempts to locate terminal server license servers using a predefined discovery process. The method used is dependent on the server environment and the mode in which the licensing server is configured to run. You can override the discovery process by modifying the registry to point to a specific license server or servers. Under Win2K, you can specify only a single licensed server in the registry, whereas WS2K3 lets you list multiple preferred licensed servers. To override the discovery process, add subkeys to the /local_machine/system/current control set/services/term service/parameters/license servers subkey. Each subkey should be named with the host name of the licensed server that you want the terminal server to use. Name few terminal services utilities available in the Windows Resource Kit. Apps, used to restrict non-administrative users' execution access to a limited set of authorized programs. Drive share, used to share and connect to local drives during terminal services client session initialization. File copy, provides copy-paste file transfer between a terminal services client session and a local desktop. LS report, used to connect to terminal services licensed servers and display information about the license key packs installed on the servers. LS view, used to display the name and type of currently available licensed servers in a domain. RoboClient, a terminal services capacity planning tool. SimClient, a terminal services capacity planning tool. SREG, a graphic utility to change client registry settings relating to bitmap caching, glyph caching, and so on. Server, used for allowing or disallowing client connections based on the client version. Winsta, used for monitoring terminal services client sessions. Explain the terminal services modes available in W2K/W2K3. There are two different terminal services modes available in Windows Server 2K/2K3. Remote Administration Mode. Terminal Services Remote Administration Mode allows any server running Windows 2000 Server, for instance, a domain controller, or back-office server, to be administered remotely with full access to all the built-in graphical user interface-based, GUI-based, administrative tools, as if the administrator was sitting right at the server. Within Windows Server 2003, Remote Administration Mode is built in and does not need to be installed. This ability to administer the server can be made available from any client device, including a legacy version of Windows, or even non-Windows-based clients. This server management feature is an invaluable tool for quick and easy administration of large and small-scale networks. Terminal Services has two built-in per-server connections specifically for remote administration. A Terminal Services Client Access License, CAL, is not required to connect to terminal services in remote administration mode. Application Server Mode. In Application Server Mode, applications can be deployed and managed from a central location, saving administrators initial development and deployment time as well as the time and effort required for maintenance and upgrades. Once an application is deployed using terminal services, many clients can connect whether through a remote access connection, local area network, LAN, or wide area network, WAN. The clients can still be Windows-based, Windows CE-based, or even non-Windows-based. Licensing is required when deploying a terminal services-enabled server as an application server. You can install Windows 2003 Server terminal services in either of two modes, Remote Administration or Application Server. Remote Administration mode installs only the remote access components of terminal services and performs with very little overhead, so it's ideal for mission-critical servers. Terminal Services in Remote Administration mode permits a maximum of the two concurrent remote administration connections. No additional licensing is required for those two connections, and you don't need to run the Terminal Services licensed server. Application Server mode installs the application sharing components of terminal services in addition to the remote access components. This mode lets users run applications remotely. However, running terminal services in Application Server mode requires you to purchase licenses and set up a terminal services licensing server within 120 days of installation. For administration purposes, you should install terminal services in Remote Administration mode. Remote Administration mode minimizes the impact on server performance while still facilitating remote administration. When I try to log on, Why do I get the error message, unable to log you on because of an account restriction? This message can appear because a user trying to log on is not in the remote desktop users group, or because an account has no password. Starting with Windows XP, accessing network resources such as remote desktop and file shares requires that you have a password associated with an account. When I attempt to update terminal services using Windows Update, I receive an error stating that I should be in install mode. How do I activate install mode so that I can install available updates? You must use the command prompt to activate install mode. At the prompt, type change user/install. This command performs the upgrade. When the upgrade is complete, type change user/execute. Can I use my current Windows 2000 license server and CALs for Windows 2003 terminal servers? No, the Windows Server 2003 needs a new version of CALs. You need a Windows Server 2003 license server, which can serve both Windows 2000 terminal servers and Windows Server 2003 terminal servers. How do I connect more than 2 users to Windows 2000 Server or Windows Server 2003? How do I connect more than 1 user to Windows XP Professional? If you are running remote administration mode on Windows 2000 or Windows Server 2003, no more than 2 concurrent users are allowed, and there is no way to increase this unless you change it to Application Server Mode. Application Server Mode requires client access licenses and a licensing server. If you are using Windows XP Professional, this number is limited to 1 remote connection and there is no way to increase this number. What port does RDP use? By default, RDP uses port 3389 for all of its traffic,